Sun appeared about 4.6 billion years ago as a growing star in an ordinary arm of the Milky Way galaxy. The Sun is a star that gives life to many structures in the solar system and can be considered their source of existence. Especially for our planet, it is an extremely, perhaps even the most important detail. Because the disappearance of the Sun would mean the disappearance of many things that serve as the source of life for humans. But do you think the Sun could disappear anytime soon? And if it does, what could we do with today's technology? Today, we're going to take a detailed look at the Sun, talk about when it will disappear, and discuss what we would face if it suddenly vanished. Before we start our video, don't forget to subscribe to our channel, like our videos to help them reach more people, and share your thoughts in the comments for new video ideas. Now let's dive deep into the Sun together. As we said at the beginning, about 4.6 billion years ago, there was a cloud of dust quietly drifting through an ordinary arm of the Milky Way galaxy. This dust cloud mostly contained hydrogen, a small amount of helium, and remnants of heavier elements. After a long time passed, a nearby supernova explosion caused the dust cloud to be shaken violently and collapse in on itself. This collapse was the very first step that began the formation of our Sun. Later, as the cloud became denser toward its center, the temperature and pressure increased enormously. During this process, which lasted millions of years, the center eventually became so incredibly hot that hydrogen atoms began to fuse together and form helium. We can truly say that this was the moment the Sun was born. It was as if this star began to burn and shine like the cry of a newborn baby. The nuclear fusion reactions that started billions of years ago are still continuing today. Although the surface of the Sun has a much lower temperature than one might expect, its core is about 15 million degrees Celsius. At this incredible temperature, the nuclei of hydrogen atoms, that is, protons, combine under the influence of the strong nuclear force to form helium. It is often said that a small portion of the mass is lost during this fusion, but in reality, it is not destroyed. The reason people describe it this way is to make it easier for those who are interested in these topics, but don't study them scientifically to understand. But let me tell you what this so-called disappearance really means. As we said, the main role is carried by mass, but thanks to Einstein's famous E=mc² equation, that seemingly lost small portion of mass turns into a source of energy. And this energy is what represents the enormous power the Sun emits into space every single second. I can explain to you how powerful the energy produced by the Sun truly is in the following way. The amount of energy the Sun produces in just 1 second is trillions of times greater than all the energy ever produced in the entire history of humanity. Just imagine it. Picture the storms and energy eruptions happening inside the Sun. In fact, when determining the level of advancement of a civilization, one of the key factors is whether it can harness the energy of its own star. You may have heard of the classifications, Type 0, Type 1, Type 2 civilizations. Unfortunately, we are still far from even reaching Type 0. A highly advanced civilization would have access to almost unlimited energy by harnessing the massive power of its star. Anyway, we'll talk about that topic with you in another video. Now let's get back to our Sun. Every single second, about 4 million tons of matter in the Sun are converted into energy. This energy first travels through the outer layers and then moves toward the surface. But this journey isn't as smooth or easy as it may sound. A photon created in the core can take hundreds of thousands or even millions of years to reach the surface of the star. Because as these photons travel upward, they collide with other particles, just like crashing cars, bouncing around and scattering in all directions. Eventually, after this long process, the photons that reach the surface are released into space as energy, light, and heat. The light from the Sun takes about 8 minutes and 20 seconds to reach Earth. This means that if the Sun were to suddenly disappear, we would only realize it 8 minutes and 20 seconds later. In other words, you could say that when you look up at the sky and see the Sun right now, what you're actually seeing is the Sun as it was 8 minutes and 20 seconds ago. You're essentially looking into the past. This shows us how space hides secrets about time itself and raises fascinating questions about whether time can actually be controlled or manipulated. And of course, that's a topic we'll talk about in another video, as always. So don't forget to follow our videos. Anyway, the surface of the Sun, called the photosphere, is, contrary to what many people think, a relatively cooler region. It has a temperature of about 5,500 degrees Celsius. Above this layer are the chromosphere and the corona, the outermost layers. But let me tell you something even more interesting, my friends. As you move away from the surface of the Sun, the temperature actually starts to increase again. In the corona region, temperatures can reach millions of degrees just like in the core. When scientists discovered this, they were shocked and studied the phenomenon for a long time, trying to understand why. Because as all of you would logically think, the farther you move from a heat source, the cooler it should get. But here it's the exact opposite. Although the exact reason for this is still not fully understood, scientists believe that magnetic fields and plasma waves play a very significant role in this temperature increase. Our sun is not just a source of light or heat, it's a titanic magnetic beast. On its surface, gigantic magnetic fields constantly form, twist, and snap. These processes cause what we know today as solar flares, which have become quite popular recently. These flares can be so powerful that they can disable many of our technological devices on Earth and even satellites in space for a certain period of time. Even more impressive are the coronal mass ejections, massive eruptions in which billions of tons of plasma are hurled into space. If one of these eruptions is directed toward Earth and interacts with our planet's magnetic field, it creates what we know as the auroras, or the northern and southern lights. And as you already know, every year thousands of people travel long distances just to witness these lights. Our sun completes one magnetic cycle every 11 years. During this cycle, the number of sunspots increases and then decreases. Sunspots are regions on the surface that are relatively cooler than their surroundings. Though cool is quite relative here, because even these areas are still thousands of degrees hot. These cycles are crucial for understanding how active our sun is. In fact, they can even indirectly influence Earth's climate systems in subtle but noticeable ways. Now let's get to the most striking question. Will this massive star, the one that gives life to countless structures and millions of living beings on our planet, continue to shine and sustain us forever? Sadly, no, my friends. Compared to other stars, the sun is actually middle-aged. It's about 4.6 billion years old, and it will continue to shine for roughly another 5 billion years. But at the end of that time, it will die. Right now, its hydrogen fuel is slowly running out, and one day when that hydrogen in the core is completely depleted, the sun will lose its balance. As the core contracts, the outer layers will expand, transforming our sun into a gigantic red giant. Now, 5 billion years might sound like a very long time, and it really is. But as the sun's fuel gradually runs out, Earth's inhabitants will begin to feel its effects long before that. In fact, we've already started to. The climate will change, plants will lose their ability to photosynthesize efficiently, and oxygen production, along with carbon dioxide absorption, will decline. Meanwhile, humanity, already damaging the planet's natural balance and increasing carbon emissions every year, will make this process unfold even faster. However, it's very likely that the true consequences will be faced by generations 3 or 4 after us. Anyway, once the sun becomes a gigantic red giant, its radius will expand enough to reach Earth's orbit. By then, Mercury and Venus will already have been swallowed by the sun. As for Earth's fate, it's uncertain, but most likely it will suffer the same end as those planets. At first, Earth will become unbearably hot, leading to enormous wildfires. Changes in its orbit will trigger massive earthquakes, tsunamis, and devastating floods. Even if the Earth itself isn't completely destroyed, it will no longer be habitable. This red giant phase will be much shorter compared to its current, stable phase, lasting only a few 100 million years. During this period, the sun will blow away its outer layers into space, leaving behind a dense, hot core, what we call a white dwarf. This white dwarf will no longer produce new energy. It will simply cool down slowly over billions of years. When it eventually cools and darkens, it will become what astronomers call a black dwarf. The same sun that once gave life, warmth, and the gift of photosynthesis to our planet will, one day, fade into the darkness of its own ashes. Yet until that distant future, the sun will continue to be the source of all energy that sustains life on Earth. And as long as humanity exists, everyone who looks up at the sky will see not just a star, but a reflection of their own emotions, their own dreams, and their own path. In the grand story of the universe, everything that lives, whether it's a star, a planet, or a person, follows the same inevitable cycle: birth, growth, and finally death. Our sun and our Earth are no exceptions. What would happen if the sun didn't disappear over billions of years, but instead vanished all at once? First of all, don't worry. This is completely impossible. But still, Let's imagine it as a scientific what-if scenario and explore it as realistically as possible. At the exact moment the sun vanished, we wouldn't feel or notice anything at first. That's because, as I mentioned earlier, sunlight takes about 8 minutes and 20 seconds to travel from the sun to Earth. So for those few minutes, everything would appear perfectly normal. The sky would still be bright, winds would blow, and life would continue as if nothing had happened. But after those 8 minutes passed, darkness. The entire planet would be plunged into total night. At first, we would see the stars of the universe shining in their purest form, but soon artificial lights would kick in, and the stars would fade again. From that moment on, Earth would no longer have days or nights, just an endless, eternal darkness. This sudden loss of daylight would have devastating psychological and physiological effects on humans. Our bodies and minds are deeply tied to the rhythm of light and darkness, and without it, our sense of time and balance would collapse. The next and perhaps biggest impact would come from gravity. The sun's gravity is what keeps every planet, moon, and asteroid in a stable orbit. Without it, that entire cosmic order would vanish. Every planet, including Earth, would suddenly fly off into space, like stones flung from a slingshot, drifting in random directions through the void. Without any source of light, heat, or energy, Earth's temperature would start to drop rapidly. Humanity, completely unprepared for such an event, wouldn't stand a chance. Except for a few plants kept in controlled greenhouses, all vegetation would die within days. The planet's average surface temperature, normally around 15 degrees Celsius, would drop to minus 20 degrees Celsius within days, and after a week, it could reach minus 70 degrees Celsius. The oceans would freeze solid, the soil would harden like stone, and the Earth would become a barren, icy wasteland. Even the upper layers of the atmosphere would freeze, clouds would collapse, and snowflakes themselves would crystallize midair. Frozen in time, the sky would no longer move. We would be staring into a completely motionless, lifeless heaven. If humanity failed to prepare, and let's be honest, with our current technology, oxygen levels would soon drop. Without plants to perform photosynthesis, oxygen would stop being produced, and within about a month, Earth would become a completely frozen, airless world. Now, could anyone survive such a catastrophe? Maybe, just maybe, a small group of people in highly advanced, secret underground bunkers could endure for a while. These facilities would need to be fully self-sufficient, capable of generating their own food, energy, and air. But even then, one small malfunction could freeze the entire system solid and render it useless. So while humanity would almost certainly perish, life itself might not completely vanish. Deep beneath the oceans, where liquid water could remain unfrozen for a while, some microorganisms might continue to survive, silently in the last remaining pockets of warmth. And there you have it, my friends. Based on my research and calculations, that's how things would unfold if the sun suddenly disappeared. Of course, everyone can imagine this scenario a bit differently. So tell me, what do you think would happen? Let me know in the comments. That's all from me for today. I'll be diving into new research, hunting for reliable sources, and preparing the next big video for you all. Don't forget to subscribe, like the video, and as always, take care of yourselves. See you in the next one.